Hey Pre-Calculus, in this video we're going to review complex and imaginary numbers, which you learned in Algebra 2, and we're going to expect you to remember it, so this is just a quick review in case you don't. So first, what's the difference between a complex number and an imaginary number? And I'm going to make my notes look pretty. You can fast forward if you want. Just in one of those moods, you know. Alright. Complex numbers versus imaginary. Alright, so what's the difference? So a complex number is a number that can be written in the form a plus bi, and it's really important. This is just the format of it. It needs to be a plus bi, so constant plus imaginary number. A and b are real numbers. I is imaginary. AKA square root of -1. So then moving on, imaginary numbers, this is any number that's bi, and then b is a non-zero, so that would just cancel it. Real number. And I is square root of -1. Okay, so there are a couple things to just go over. You need to be able to simplify, solve. So one thing that you want to make sure you remember, oops, forgot the E in remember. Okay, so you want to remember that the simplest form of I is I, so this is just I to the first power. So I to the first power. We don't put that one there, but it simplifies to I. You need to know I squared, which you could figure out by just taking I, which is the square root of -1, and squaring it, and that would give you -1. You need to know that I cubed is equivalent to, and you could solve for it, so you could think of it as I squared times I, which is -1 times I, so this is -I. And then finally, I to the fourth is I squared times I squared, which is -1 times -1, which is +1. And the reason we stop here is because it continues to follow this pattern. You only need to know the first 4. So I is equivalent to I, and I mean the good news is like if you didn't know it, as long as you know what I is, you could do the math and figure it out every single time. So imaginary numbers are going to come up. They come up in solving. You need to understand how operations work with them. Basically everything you need to know is on page P7. So if you go to your book, you can see page P7 for examples. And your book does a really great job of walking through the steps. I'll go through complex conjugates in this video real quick, just because students tend to really struggle with complex conjugates, but you could also just stop the video now and go to page P7. So a complex conjugate and conjugates in general are just going to be super important. Okay, sorry. So complex conjugates are complex numbers with equivalent real parts and opposite imaginary parts. So, for example, 7 minus 8i, the conjugate would be 7 plus 8i. So it's just the opposite, like the imaginary part is just the opposite sign. So if I had negative 2 plus I, the conjugate would be negative 2 minus I. So the only thing that changes is the imaginary number. And the reason for that is so that you can cancel them out. So what I mean is if you had a division problem really is where they come into play. Because we don't want imaginary numbers in the denominator. We don't want anything irrational. So if you had 2 over 3 plus 6i, well, this isn't simplified. We need to get this out of the denominator. So what you can do is you can be sneaky and multiply by 1, which you're not actually multiplying by 1. But something over itself, right? 2 divided by 2 is 1, 3 divided by 3 is 1. So we'll multiply by the conjugate. So that'll be 3 minus 6i. And so if we multiply it in the denominator, we multiply it in the numerator, so that's why we're kind of just multiplying it by 1. It's just being super sneaky. And then I'm going to show you, I guess, I'll show you in this pink color why it works, but you don't have to show this work. So when you distribute, right, 2i times 3 would be 6i. 2i times negative 6i is negative 12i squared. And this is why we do it, because in the denominator, you distribute, so 3 times 3 is 9. 3 times negative 6i is negative 18i. And then 6i times 3 is positive 18i. And then 6i times negative 6i is negative 36i squared. So the whole reason we multiply by the conjugate is really this right here. So these are going to cancel. So what you would really just need to show is the numerator. So you could go straight to this step if you wanted to. And then remember, you have to remember these things up here. I squared is the same as negative 1. So this is just negative 1. I guess I could show that in an extra line for you guys. So this is actually 6i minus 12 times negative 1. and this is 9 minus 36 times -1. So by multiplying by the conjugate, you get these to cancel out, and then I squared cancels out your imaginary numbers. Ran out of room. So this would be positive 12, and the constant goes first, plus 6i over, and then this is 9 plus 36, so that would be 45. And then can we reduce? Yes, we can. So these are all divisible by 3, right? So do remember that when you're simplifying, you're simplifying it like as if it was written this way. So just keep that in mind. If these are two different denominators, you'd have to separate them, but it actually works out. So it's what, 4 plus 2i divided by 15. And then we're done. So if you want more practice, go to P7, because you need to be able to do basically every single example in that section. But most of it's review. You've done it before. So I'm just going to show you this one example.